Hello everyone, welcome to my channel Chemistry is Fun. Today we will study about the chapter solution for class 12 CBSE. Now see, first of all let us understand one thing, that in normal life whatever we see around us, most of them are certain type of mixtures. We usually do not come across pure substances maximum of the chances. Now see, these mixtures contain either two or more than two pure substances, and they are of utmost importance in our daily life. Like see, we use so many alloys like steel or brass. These properties are different in different alloys. Brass is different from bronze. Bronze is different from steel. Now we also need to understand that in case of mixtures which we see around us, the proportion of each component should be within a limit so that it can be used in our daily life. Because you see, 1 part per million of fluoride ions, which is, if it is present in water, it will prevent tooth decay. But 1.5 ppm can cause the tooth to become mottled, and high concentration of fluoride ions can be very poisonous. Because we know that in case of rat poison, sodium fluoride is used. So this is one part. We also know that there are certain solutions which can be life-saving. Like intravenous injections are solutions in water, and they contain salts at particular ionic concentration. And it should be such that they can match with the blood plasma concentrations. So here we will be studying liquid solutions and their formation. We also need to study the properties of the solutions. So let's get started. First of all, we need to see what the solutions are. The solutions are homogeneous mixture of what? Two or more than two components. Now what is homogeneous? Homogeneous means that the composition and properties should be uniform throughout the mixture. And in a mixture, the component which is present in large quantity is known as the solvent. It is present in largest quantity. So within solution, the component which is present in the largest quantity is the solvent. And this solvent only will determine the physical state in which the solution will exist. There will be one or more component in the solution itself other than the solvent, and we call them solutes. So they are other than solvent. What do we call them? Solutes. Other than solvent, solutes are also present in a solution. Now here we will mostly concentrate on binary solution, means two components will be there. The components may be solid, liquid or in gaseous state. Each component may be solid, liquid or in gaseous state. Now first of all we need to understand how we can express the concentration of solution. If we want to describe the composition of a solution, for describing the composition of a solution, we have to express its concentration, either qualitatively or quantitatively. By qualitative, what do we mean? We say that the solution is dilute. Dilute means the amount of solute is relatively small. If we use the term concentrated, it means relatively large amount of solute is present. But here we are not very clear. Dilute means how much solute is present? We can't understand. So there are different ways by which we can tell about the concentration quantitatively. So let us see them one by one. So here what we are discussing is the Concentration of solutions. First is mass percentage. What do you mean by mass percentage? From the name itself we can understand it is a percentage and something related to the mass. So how we can calculate? This is mass of the component in the solution divided by total mass of the solution multiplied by 100. So mass of the component in the solution means we are calculating the mass percentage of a component. There will be at least two components if we are considering binary solutions. So mass of the component in the solution divided by total mass of the solution multiplied by 100. Like if we say 10% glucose in water, 10% glucose in water means 10 gram of glucose and total solution should be 100. So then rest is water, 100 minus 10, 90. So 10 gram of glucose in 90 grams of water. So if we say 10% glucose, solution. So how much is glucose? 10 grams of glucose. And how much will be water? 90 grams. Okay. Next is volume percentage of a component. Volume percentage of a component will be volume of the component divided by total volume of solution multiplied by 100. So if we say 10% ethanol solution in water, so it will mean 10 ml of ethanol dissolved in water so that the total volume of the solution is 100 ml. So volume of the component by total volume of solution into 100. Okay. So in 10% ethanol solution in water, how much will be this ethanol? 10 ml ethanol. And in that case, what is the volume of solution? Solution will be 100 ml. Next comes parts per million. If the solute is present in very trace quantities, then we express the concentration in parts per million referred to as ppm, and it is defined as number of parts of the component which we are considering divided by total number of parts of all the components of the solution into 10 to the power 6. Okay. So this is used in case where the solute is in trace quantities. Now we will go through some numericals. Let us see one by one. First one, calculate the mass percentage of benzene and carbon tetrachloride if 22 grams of benzene is dissolved in 122 gram of carbon tetrachloride CCl4. For benzene, what is the amount? 22 grams. So 22 divided by total mass, because we are calculating mass percentage. So denominator will be total mass of the solution. So it should be 22 plus 122. On calculation, we get 15.28%. It's very simple. For mass percentage of CCl4, amount of CCl4 is 122, so it is 122 divided by the total mass, 22 plus 122. On calculation we get, and we have to multiply by 100. It is 84.72%, 84.72%. Next one is good one. Calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. So 30% by mass, if we take the total mass to be 100 grams, then mass of benzene will be 30 grams because it is 30% by mass. So mass of CCl4 will be 100 minus 30, that is 70 grams. Now if we want to calculate the mole fraction, first we need to know the number of moles of benzene and number of moles of carbon tetrachloride. To find out number of moles, we need to know molar mass of benzene because given amount we know. One is 30 grams, another is 70 grams. So molar mass of benzene C6H6. Carbon atomic mass 12 into 6 because 6 atoms, to 6 into 12 plus for hydrogen 6 into 1. So 72 plus 6, that is 78 grams. Number of moles of benzene. Number of moles of benzene 30 by 78, that is 0.3846 moles. This is for benzene moles. For CCl4, number of first we need to calculate molar mass of CCl4. Molar mass of CCl4 will be 1 into 12 plus 4 into 35.5. That is 12 plus 142. On calculation we get, on multiplying and all, we will get it as 154. Okay. Next we calculate number of moles of CCl4. We can do it here. Moles of CCl4. That will be 70 because that is the mass divided by 154. So that is 0.4545 on calculation. So this is the number of moles of CCl4. To calculate the mole fraction for benzene, that is C6H6, we will put the number of moles of benzene, that is 0.3846, divided by total number of moles. So what is total number of moles? 0.3846 plus number of moles of CCl4, 0.4545. On calculation, we get it as 0.458 on calculating. 0.458. So I hope students you all could understand the topic which I discussed today. Please subscribe to my channel. Thanks for watching the video. Please subscribe to the channel. Thank you all.